So thanks everybody for coming today. If you're curious, the video I was just showing was produced by one of the guys on our team called, his name's Steve Heidelberg, and he pretty much produces them straight out of Pro. He uses GoPro video, the video editor, to splice them together, and in some cases add a couple of titles, but most of it is now coming straight out of Pro. I bet you that 2 years ago you would not have thought that you would have seen something like that coming straight out of a GIS desktop product. But that is part of what we're here to talk to you guys about today, and it's hopefully over the next few years we'll see even more really easy to use, achievable, accessible, and exciting stuff like that. So welcome to the 3D Across the Platform talk. It's an updated version of a talk that we've been doing for a couple of years now. I'm Chris Andrews, and I'm really lucky to have two guys with me here to help present. Eric Wittner here is the product manager for City Engine and Procedural Technologies. And Eric has got a great history with Esri and has been in sales, been a product engineer, and then now has been a product manager for the last 2 years. And then Brian Sims over here. Brian and I actually worked together briefly in a prior life. I did some work for him when he was with the city of Pasadena, and he joined Esri in about 2010 and is now working with 3D cities and indoor GIS and lots of other stuff that we're getting asked about all the time. So then I am Chris Andrews. I've been around the Esri community for almost 20 years, but I've only joined Esri about 2.5 years ago. This is my third Dev Summit. And I'm the 3D PM, kind of like Peter Becker is the imagery PM. So Peter Becker goes around irritating all the other PMs about imagery. I go around irritating all the PMs about 3D. So hopefully you've seen some positive effect of that over the last couple of years. All right, so 3D at Esri. A lot of people didn't get my very subtle message with this slide. So what I say is that geospatial 3D is already all around us. But what that tidal wave there means is that it's more than all around us, right? If you go talk to Vexcel or Cyclomedia or Harris Corp or any of the data providers, every data provider that I've talked to in the last year and a half is either using 3D to help correct their 2D imagery, or they're directly collecting 3D imagery, or they're using 2D stuff to actually create 3D. And so if every customer out there who's commissioning new data acquisition has the option between choosing a product from yesterday that is there and cheap and that they can access, but a product from today or tomorrow that is actually got a little bit more information and won't cost them much more, you know that they're going to go for the higher value information product. And today that higher value information product is 3D. One of the arguments that I make is that 3D isn't just replacing 2D cartography, right? So I still joke with people that Esri still shows a lot of like 2D cartographic versions of 3D content. And we'll see that start to go away as well over the next few years. In fact, if you look at the range of technologies that can now be applied to GIS because of 3D and real-time and other new technologies that are being added to our field, what you actually see is that the actual pie isn't just converting to be a 3D pie, the pie is getting a lot larger. And we see this in competition. We see this in new open source APIs and SDKs that are out there. We see this in new data types that we never thought we would have to handle before. Some of the things that we're working toward and are driven by, especially for me, in the last 10 years, I've spent a lot of those 10 years focused on city scale 3D models. There's an ever-increasing amount of information about cities being driven by the fact that there's mass urbanization going around the planet. I think the statistic is that only about 50% of the infrastructure exists today that will be required to support human habitation by 2050, and cities are a major part of this. And cities are 3D. We're getting asked for spatial analytics and new types of spatial analytics. Our kids, most of us in this room, at least in high school and college, started to be able to access interactive 3D in games. Well, that means that I've got 20 plus years of experience using interactive 3D. Why can't I apply that in my daily professional life in GIS? And I think that there's an expectation these days that cadets and commanders, high schoolers and CEOs should be able to use interactive 3D in GIS to do quick and dirty GIS analysis. We still are focused, as we know our customers are, on mapping and visualization, and we'll be doing more and more around bringing really new cartographic ideas and concepts and techniques into 3D mapping. So it isn't just transferring 2D mapping concepts into 3D. It's actually bringing new stuff to bear. And then we'll be folding in additional new technologies such as real-time. It's really hard to talk to anybody in the building and infrastructure industry, in the military industries, in the UAV industry, without them wanting to add time into the equation. So it's not really 3D, it's actually 4D. I'll just adopt the extra D in my role at some point, hopefully. So we'll see how that goes. From what I'll often talk about, and I won't dive into this too much in this talk, is there are three key aspects to the way that I try to influence the teams to deliver 3D for you guys. One is cross-platform capability. We can't deliver the same thing everywhere all at once, but we do know today that 3D isn't just an extension, it's not just a separate product that works outside everything else. If you want to see point clouds on the desktop, you probably also want to see them in the web and in mobile devices, for example. So we're driving for cross-platform appropriate capability. Open. I'll talk a little bit more about this later today, but we've released a open scene specification for people to share really large content packages. They were talking about 60 billion points on that Sonoma demo. A lot of people probably didn't catch that. It's 60 billion is what they're talking about. We have a scene caching format that allows you to take LAS files and cook them into a smaller format that allows you to actually serve it out much, much, much faster. And you can go play with that stuff up in ArcGIS Online today. Accessibility. As I started off with, a huge goal for me in my career has been delivering software that is easy enough for professionals to use without having to think about the software. And that, for me, as I started off in the Esri world doing customization, and it was my job to make GIS software work for realtors and scientists and other people who don't want to think about the GIS tools. And I think what we're seeing these days is that there's a general consumerization and expectation about technology that is driving for easier use, more user-friendly software, and that's the other thing that I focus on. When it comes to products, I'll run through some of the products just so that you guys can kind of see and hear how we talk about them. ArcGIS Pro is basically the professional GIS desktop authoring tool. The best analogy that I've heard for anybody who's familiar with Autodesk Max or Maya is that ArcGIS Pro is to GIS what Max and Maya are to the entertainment industry. You can, for one thing, just like map, right? The typical GIS person doesn't spend 100% of their time in 100% of map, right? They spend 80% of their time in 10% of map and maybe another 10% of their time or 20% in another 10% of map. Well, that's how Max and Maya work in the entertainment industry. Those tools are used to curate content, generate content, munge content into new things. That's what Pro is for. They are used not as much for analysis. Pro definitely has the power of all of the geospatial and analytical tools that we have in the GP tools. But something else that those tools are used for is generating content directly that can be shared with other users, like videos. And that video that I showed you at the start was one perfect example of that. Map layouts, right? All those things that are products, traditional products that we still need to produce and share. City Engine is something that Eric's going to talk about in depth, but I'll just say I'm really excited to start to see it differentiating away from some of the other products, but also becoming part of the platform. And it's a really great credit to Eric on helping to drive this priority over the last couple of years. And we're now starting to see feedback come in that it's actually working. And so he'll talk a bit more about what we're doing there. ArcGIS Earth has been about 50% of my time for the last year and a half, and it was never intended to be. The whole strategy there is swapping out Earth for Google Earth, and I'll talk a little bit more about that. What I expect to see, a lot of people ask me, mobile 3D is the third highest requirement that we get in terms of priority from folks like you. But a lot of people inside Esri say, well, why do they want it? What do they want to do in 3D? It's just GIS, folks. I expect in 5 years for there to be 15 different apps that will all be 3D apps that all do different things with 3D GIS. And you can hold me to that if it happens or not. Anyway, let's see. We have a whole bunch of 2D apps as well, and I'll ask you, it's a little bit of a trick question, as was pointed out yesterday, but does anybody know the best, most often used tool for integrating building information modeling workflows and GIS? And some people might have been in my talk yesterday, so don't cheat. Anybody have any idea? Any red badges even? No. Collector. Collector is the most common tool used by civil engineers to tie together their infrastructure workflows and GIS workflows, and it's because they use it to collect and audit GCPs, right? So we find that even some of the 2D apps are usable in 3D workflows. All right, and enterprise, all I'll say about enterprise is an online, you make the most value out of the GIS platform with 3D when you can host and serve out 3D in one of these. You guys can go up today and play with 3D and online and experiment with our WebGL capability. You just go right to arcgis.com and click on the scene button and you can explore the globe. And you're exploring terrain, elevation, and imagery, a variety of base maps actually that are just served out there for free. Then you can add a lot more to it. I love the new ArcGIS Enterprise packaging because it makes my life much easier when people ask me what do they need to have for on-premises 3D. What do you need? You need Enterprise. The packaging that is in Enterprise has everything that you need for on-premises 3D. So it's much easier to tell that story this year than it was last year. Last year was you need Portal and a federated server, and all that stuff. You need Enterprise. So if you want to be on-premises with 3D. Content. Brian's team has been partly responsible for driving tons of great content for us, actually mostly responsible for it. And then we have other content, 2D content that can be used in 3D. I expect to see a lot more content coming out of Esri in the future. Did anybody hear that this PokeVision app that was using Esri services last year, did you hear the numbers around it? So we had a company just plug into our public services and use our base maps. And they drove our daily map requests from 500 million to 4 billion a day because of people looking for Pokemon, right? But it's testament to the scalability of our stuff and the Amazon cloud that it's in, and it also just shows you that we serve out stuff for people to use to innovate with, and there are many other stories that aren't quite as entertainment related as that, and therefore don't have quite the volume, but are still actually delivering more value for users than PokeVision. But no offense to the PokeVision guys if anybody's in the room, which I don't think so. And then developer tools. I started using Esri. I started programming in Avenue the first day I ever touched an Esri product. So I have a deep, intimate familiarity with the development story at Esri. And we are, 3D is part of that, right? We have 3D in the 10.2.6 Windows runtime. We have 3D now in all the new Runtime 100s, and it will be in production for mobile in May, June, whenever that is live. We have a planned API for Earth around the corner, and then Pro has an API that we're starting to see more extensions on top of. I've been using Python for 12 years or so, and I'm a big believer, a long time before most of the rest of the GIS community adopted it. And JavaScript too, I've been using that since the late 80s, or late 90s, I mean. One thing that I'd say before I jump into the other parts of this talk is that the customers that want 3D are the same customers that we had yesterday and that we have today, right? It's if you break up the customers who are using 3D into these kind of familiar stories, there are some customers that just are small enterprises that want to host everything that they have in the cloud and that just want a few little custom apps that they are actually configured apps without a lot of developer activity. Then you've got large enterprises that want extensive customization, they want to host their own stuff on premises, and then you've got these complicated hybrid customers. And they're the same customers that we've had for years, and they will continue to be, and they just want new stuff, real-time, 3D, other things. All right. Earth, we have a new product manager on the team named Darren Pustum. He is taking on ArcGIS Earth as the product manager, but it's still under me, and I've been driving it very heavily for the last couple of years. Earth is a lightweight globe desktop application that was unashamedly designed to replace Google Earth in these big enterprise customers who are losing it. In the US government community, I estimate that it's several 100,000 desktops that are transitioning away from Google Earth eventually. So it's non-trivial, right? And Esri was already in a lot of those customers as the server, so we realized that when Google said they were going to pull out, that we needed to offer something to replace the client piece, because those customers still depended on us one way or the other. Earth, rather than read the laundry list, you all should go download it for free, assuming you're a Windows user, and use it, try it. Both Darren and I have taught elementary school classes with it, and the kids love it. So if they can figure it out, I have high confidence that the group in this room can figure it out. There's a trick workflow where you can actually configure a secret click that is actually widely used in certain government communities, where you can hook up to a service on the back end. And I have an example on this machine where I have a little Python Cherry Pie server, and as long as I return KML, I can get Earth to display whatever I want. So like last year I showed embedding the Google Street View in ArcGIS Earth using this mechanism, and you can do things like execute a buffer in the back end. You can do whatever you can imagine. I have another example that places moving drones that then are network links that update, and so there is actually a mini developer workflow today. We have in the short term, probably at the UC release, we're looking at releasing a simple API for Earth that will allow app-to-app integration, and then there will be more after that. All right, CAD and BIM, and I'll promise I'll be pretty quick here. So CAD and BIM, I was at Autodesk for 7 years. I was never a CAD person. I was hired there because I never touched Autodesk products. But everybody here assumes that I'm a CAD guy because of that. So I'm not really. Don Keeney is the guy who works with us, who is the product manager for ArcGIS for AutoCAD. He was a civil engineer. He knows CAD way better than I do. But fundamentally, GIS users are asked to use CAD data as either data for analysis or to generate really interesting maps. And that need is not going away anytime soon. CAD data is not going away at all anytime soon. ArcGIS for AutoCAD is this free plugin that has literally tens of thousands of users. And what we've found is that some of our partners actually use it to go and sell more work, especially around customized workflows for integrating CAD and GIS. And there's actually often a lot of development services type activity around that. BIM now is building information modeling, is replacing CAD gradually in a couple different ways in a couple different markets. And what we're finding is that people want BIM to be used for the same kinds of things. I want BIM to be used for the campus map type experience over on the left, and then I want BIM to be used for visualizations so that I can not only see what the desk looks like in the room, but I can see out the window to the new donors building on the other side of the quad. You know, that's the type. Those are very common workflows that we're being asked for today. As Don said yesterday, about 50% of his time and mine now are spent talking about BIM GIS. Oops, sorry, didn't mean to go forward there. Today, the BIM to GIS workflow is non-trivial. It typically requires safe software FME or something like that. We have workflows that you can ask us about, and we have a really experienced professional services team that has a lot of examples, sample code, all kinds of stuff that we can give out to you guys to use to do improved BIM to GIS integration. We also have some efforts to further improve that and streamline it that should be rolling out in the next year or so. Today, for 3D on the web, what we're getting asked for a lot is, let me put 500 buildings in the same web scene. And as I've said to the team, you know, we opened up a little pipe, and then people basically try to shove really big things through it. And there's a workflow for that. You establish a data store, you publish with an EGDB, you publish your BIM data into it. You can generate scene layers and then start distributing those out to others. You can generate scene packages and move those to other systems, and then you can even locally use data. And there's all kinds of potential around this. And we have a lot of work to go there. And then something for the not too distant future is we have some experiments around directly reading Revit data. Revit is a 3D architecture platform product, and we have some direct read efforts going on as well, so that a GIS person could just open a Revit file. So, all right, so now to Eric.
Yep, can you switch to one?
Oh yeah.
So I just wanted to talk a little bit about Procedural and the ArcGIS platform and where City Engine and Pro are going. Of course, the reason why we're interested in procedural technology is it gives us this ability to create a rule. That rule allows us to express a design. It could be a building, it could be a streetscape. It could actually just be a type of symbology or potentially a piece of vegetation. But once we write the rule, we can repeatedly use it and modify it just by changing the parameters of the rule. So it gets this kind of rapid, repeatable process where we can do two things. One is we can make large scenes very, very quickly. So if I have LiDAR information for a whole county like Miami-Dade, I can go out, use the LiDAR to extract out the building footprints. From the LiDAR, extract information about the roof form, push that through Procedural and actually get a bunch of buildings and houses that actually have almost true to form roof forms very, very quickly, very, very easily. So that rapidness lets me do large amounts of data. The other thing it lets me do is do small amounts of data many times. So if I'm a design professional and I'm doing multiple design alternatives, I can create many alternatives quickly. And because it's procedural, these things can actually generate metrics and performance information about them, so I can compare them and see which one is the best one and evaluate those alternatives and picks the best one. So it's really it's a cost-saving tool. And it's being used in a variety of places. A couple years ago, Singapore did a nice presentation on using it to do kind of district scale planning and zoning design in Jurong Lake. So if you're very interested, I definitely recommend checking out the video of them doing that work. Household Levine has been using it to do design at a much smaller extent, looking at neighborhoods and individual neighborhoods and interoperating with things like CAD and SketchUp to bring designs into that are 2D and then just applying rules to make them pop up and become 3D objects very, very quickly. And then also we have partners that are building solutions on top of things like ArcGIS Pro extensions that use procedural technology to do kind of comprehensive planning and master planning. And this is an example from Bergman and Associates. They've actually developed a really, really nice extension that does planning on top of ArcGIS Pro. So where does Procedural live? It lives in a couple places inside of our product right now. Of course, City Engine is where it came from, so it's in City Engine. But you also have it in ArcGIS Pro. We have it as a geoprocessing tool. So you can take a set of features and a rule, combine them together, and get an output on the back end. That could be a collection of 3D buildings, or you could actually push a building into it and get a collection of, for instance, parts of that building as it's separated out. And then we have it as a visualization tool inside ArcGIS Pro that's part of symbology. So you can use it and apply it as a symbologic style to create something snappy looking in 3D. So just to touch what's coming in City Engine for 2017, right? We're really kind of pivoting what City Engine is focusing on. It's really going to become more of like a building designer, an urban designing tool, tightly focused on that market, all about kind of rapidly creating 3D in that space and then doing comparisons of what you've created. So there's a couple of kind of interesting new capabilities coming with it. The first one is scenarios. So within City Engine, you can, as you're creating your design, your city, you can select an area of it, substitute it out and say, okay, that's existing condition, and then make alternative A, B, and C there, drop in different alternatives, compare them side by side, edit in them side by side, share features between them. So scenario A and B can share a feature, but C doesn't have it. And then actually do metrics and comparisons and dashboards, which are scenario sensitive. So I'm actually generating, for instance, let's say I'm reporting total number of office units, right, across my design. I can see those things side by side and compare them in a dashboard, and it knows how to split those out appropriately. That's, again, Chris talked about cross-platform. That's a capability that's starting here, and we're looking how we're going to design that and bring that across the platform, so it'll be honored in the web scene viewer, eventually come to Pro. Local edits. So one of the things you can do when you do a procedurally design a building is you can put handles on it. So if you imagine the building can throw up a handle and say, this handle controls my height. On screen, you can grab it and modify it, and that changes the height of the building. You can create a handle that controls the width of a window. The way Procedural worked in the past is you generated the whole feature in one go and you were done. And so you'd say the windows were 2 meters wide. Now you can say, okay, I select that building, I want to modify a window. So I can make one window narrow, or I can select all the windows in a row, make all those narrow, or I can select all windows on a floor and make those not as tall, right? So it gives me this ability to go in and change individual pieces of a procedural model, including changing the whole form. So maybe I'm stepping back the 4th floor, the 5th floor, and the 6th floor. And then on the 6th floor, I'm stepping back from a side as well. So it becomes more of a 3D modeling tool that's procedurally driven than a procedural creation tool for mass content generation. So driving it towards that design world. The language behind what procedural generates is called computer-generated architecture, and we're continuing to grow that language and grow its capabilities. What we're doing this year is starting to add context to it. So if I'm a building, I can tell myself something about what's near me. Or if I'm part of the building, I can tell. So if you imagine, I can say if I'm a parcel, every single edge can say which road is nearest to me. What category is that road? And based on that category, I'm going to get a different setback on every single edge. Or in this case, I'm a tree. I know that I have a canopy width so large. As I get closer to the edge or closer to a wall, and I know that that canopy is going to violate that wall, I'm going to shrink myself until I'm so close I can't exist, and then I'll just turn myself off. Right? So context-sensitive rule development is one of the things we're working on. And then analytics. So this is a 3D measurement tool that'll be out with 2017.0. You know, very simple, point to point, what's the distance, but it also generates the vertical distance, the horizontal distance. It gives you what we call a laser line intersection with all the buildings, so you can see what it's touching. It does that on the building, vertically on the building that you're touching. So the idea is to build these interactive tools, 3D measure, view shed, line of sight, shadow, solar radiation, right, that we can start adding, and these are all focused as interactive tools. So it's different than the way we've done these kind of analysis in the past, which is geoprocessing. These are going to be what we call design time, so near real time or within a few seconds of actually changing a feature, for instance, an observer point, you get a response. And that allows you to actually change your design based on what you're doing, what you're analyzing in the scene, rather than doing an assessment post-scene. Accessibility, of course, is something that Chris mentioned and we're concerned about with CityEngine is we want to make it easier. So we've done a lot of work on the UI and the user experience, cleaned up a lot of the toolbars and the tools to make them easier to use, simplified the navigation experience, revised the startup wizard, provided a lot more feedback in the status bar, just trying to make it a more accessible and more easy to use tool. So I talked about most of these. The last one I want to do talk is expanding the platform support. So right now inside CityEngine, you can reach out, you can get basemap, you can get elevation services, you can get polygon feature services, right, and bring those in. We're going to expand those capabilities so you can bring in points, you can bring in lines. We're going to make that a two-way sync with an update. We're going to make it a live sync so that when you make an edit in one product, you see it in the other. So we're going to continue to grow and integrate CityEngine into the platform as a 3D modeling and building creation tool. So we're going to have 2 releases for CityEngine this year, one in June and one in September, October, and we'll have betas. So if you're interested in joining the beta for CityEngine, then it'll be on the early adopters website. So Procedural continues to grow in ArcGIS Pro. We added a couple capabilities this year. One is when you bring in a procedural rule and you apply it to a layer, the rule has parameters. You assign those parameters to fields. Now when you drop that layer into the features from CityEngine rule geoprocessing tool, it basically ferrets out what those layers are, remakes all those connections, so you get kind of a WYSIWYG of what you're seeing on the screen is going to look exactly like what's being output by the rule in the multi-patch or whatever your output is. So that was a nice enhancement. And then the second one is we're also carrying the object ID of the feature through. So if you need to do a reassociation, like you need to do a join back to get the attributes from the source, you can reconnect those things after it's been created. Another thing that came out in 2016 was ArcGIS 360 VR. This was an Esri Labs project of pushing a 3D scene out onto a small VR goggle device. And what it actually is, it's the idea is that to make getting VR experiences out into people's hands really, really easy. And we had a lot of design customers who wanted a simple way that they could put in multiple scenarios in a device and then hand that to a person. They could move around from different perspectives, flip between those and see the visual impact. does this view block my, does this new proposed building block my view of the mountains in Vancouver? So what it actually is under the hood is it's a set of spherical photos that are taken at different observer points defined in your scene. They're taken for the different scenarios or states. They're wrapped into a little piece of JSON, and then they throw, if in view, what they do is they throw up, if you're looking at the 3D world, you can see the camera locations as blue camera indicators. You look at one, and you tap on the right side, and you zoom to that camera location. You look down, and you get basically a layer list of the scenarios, and you can flip between the different scenarios and see them and compare them. And since it's really just spherical photography or spherical rendering under the hood, it works on really lightweight devices like the Gear VR. And so we're going to be looking to expand these capabilities to support, for instance, 360-degree photography, be able to control more tightly which points you can move between. We're going to broaden our platform, so we're looking at making a web-based version so that, for instance, people who have just a Google Cardboard, right, can throw it up on their device and take a look at it. Trying to get it kind of a more ubiquitous and cheap and easy way to get VR into people's hands. Right now, it's authored in CityEngine, right? And then it's an item type. You post it up to ArcGIS Online or Portal, and then you just, in the app, you grab it and pull it down and take a look at it. We'll be looking at adding other authors to it, such as ArcGIS Pro and the web scene viewer in the future. So I've actually got one here, just the 2-second introduction to how to use it. You put it on. When you put it to your face, the light will come on. You look around, you look kind of like an idiot to everybody else. You find a camera, and then you just tap on the side to go to that camera, and you can change the layer list on the bottom. So I'll go ahead and pass that around. So what I want to do is actually turn it over to Brian to talk a little bit about also procedural can be used to actually create data and represent zoning and kind of more complex features. It's not just symbology. And he's got some great examples from the work that the content team is doing in terms of solutions for local and urban government.
Thank you, Eric. So I've got a whirlwind tour of various examples show you here. And am I up on 4? Yep. Excellent. So as Eric was just talking about, the kind of the handoff between procedural and overlapping that with urban planning, and this notion that we can use procedural modeling to work off of attributes and the geometry in our data to generate 3D forms. So here we see some generalized massing models in the city of Hollywood, or in the city of LA, in the neighborhood of Hollywood. These are all originally created by translating their zoning code, which if anybody's looked at zoning code, you'll read it for about 5 minutes then fall asleep, and it's about this thick in the short form. And really not, it's kind of like reading legalese. So what we want to be able to do is extract those elements out of the zoning code and translate that into a computer readable format in essentially a data model, work off of a set of parcels, use the procedural code in CGA, port that into ArcGIS Pro, and then generate these very lightweight symbols. So just working off of the parcels and values found in the zoning code, we're able to produce these massing models. Now, and a lot of times we'll see in CityEngine demos these really beautiful, gorgeous looking buildings. The purpose here is actually not to make something look finalized. It's to produce a generalized shape of what could be there, then symbolize it based on its use, red for retail, multifamily in yellow, blue in office, and get a general sense for how the future of my city could look like, and be able to kind of see the potential impacts from a visualization standpoint. And then, as Eric also talked about, being able to do those takeoff reports. So based on the square footage of each use, I could then get a sense for how many housing units I might have in my area. And with the concept of scenarios, I could have a high growth, looking at trying to bring in more office. So am I achieving my number of jobs and office square footage? Or am I going to try and do more mixed use and see if I'm going to have more continuous uses throughout my community throughout the day, and be able to kind of have more of a balanced community? Again, just translating that off of my parcel data and using procedural. So we're not only creating the massing model there, but then the wireframe, which is the maximum buildable envelope. working off of things like step backs and max height, floor area ratios, these very common things that are used by urban planners to develop urban policy. Well, there's times when we actually want to communicate what this looks like to a non-planner and communicate that to the public, be able to drop them down to a street level view and show kind of a stylized version of what the building could look like, but not go all the way to something that's final. People get kind of hung up on, well, I really don't like the color of that building. Well, this isn't the actual building that's going to get built. Let's just give you some general sense for the general massing and scale of the community. So another example of being able to kind of extend the complexity and the types of things that we can do within the code, being able to work off of the street center line and be able to create what is called a sky plane. So cities like New York and Boston, other cities around the world, want to create spaces on the street in the public environment that don't feel like a big urban corridor. And they want to kind of push back those upper floors so that we can let light down into the public space. Well, how do we go about modeling that, and how can we build a data model to be able to capture those elements? Well, in this case, what we're doing is we're saying from the street center line at a 45-degree angle, these buildings cannot pierce this sky plane. So we see that here in the first example up front, and the one right behind it in New York, they actually say above 45 feet off of the street center line, then I want you to project a 45-degree sky plane. So we're able to position the angle and then the distance off of the ground, and then say that this other object cannot pierce that plane, and then be able to generate the massing models off of that. Interestingly, other cities like and counties, County of Los Angeles, City of Cupertino, they have ridgeline protection. So they don't want houses to be able to block these views around their city. So we can take the exact same code, the exact same data model, flip this angle on its head, and have it be a downward angle plane so that houses can't be built above a certain angle, and then I can still see this protected ridge line. So trying to create reusable sets of code so that those of us like me who don't know how to program and don't know trigonometry as well as the developer of this code can actually just take these things, plug it into ArcGIS Pro and work with it, or in CityEngine and work with my data. So once I've got these massing models, well, what can I do beyond doing the reporting and the visualization of the forms? I might want to go and do some actual analysis on it. And Eric talked about the kind of real-time analysis of view sheds and visibility that's available. So now we're just looking at, again, still in the web scene viewer here, which I didn't touch on before. So this is all just very lightweight viewer, no plugin required. I just hit a URL and all this stuff loads. I don't really need to have any special software. So in this case, I'm looking at a proposed building, a fictitious building that I created in the Boston area, where they have a shadow ordinance on the Boston Commons area, this large urban park. And they have an ordinance that says that you cannot create a building that has a new shadow in this park that it lasts for over 2 hours. Well, to do that, I need to be able to understand the area around that park, and I need to be able to understand how long is that shadow on this park space from this new building. Well, I might want to do just kind of a quick look at those shadows in the viewer here, so I can turn on those shadows and see what they look like at 8 o'clock. I can move this around and quickly get a sense for it, and I could potentially turn this on and just animate it, right? Very quick, couple of clicks of a button, and I get to see the shadows in a quick little visualization that I can share and show with anyone. These shadows can also be tied to a slide so that I can hit one slide at 10, move the little shadow range over to 12, grab another slide, move it to 2, grab another slide, and just hit these slides and see these shadows move at different timestamps. So very, very lightweight way of looking at the data. But now, as a GIS professional, we understand there's times when I actually need to understand the area underneath that. So the example I was describing earlier about shadows over 2 hours. So here we're looking at the 8 o'clock time slice of shadows in Boston, and including not only the existing shadows, but then the new shadow. So this lighter shadow here is the one cast from this orange building. And I can run another tool and get just the area that is new and be able to get the area calculated underneath that. So pardon my poorly formed pop-up here, but we can see the amount of area that's within inside that, that shadow volume. And if we were to turn on our in-browser shadows, we see that they line up very nicely. And if I were to turn on and off that proposed building, I can see that shadow turn on and off in the browser. So if I were to look back at the beginning, turn on my shadows, you can see that turn on and off real time right in the browser, right? So one thing I want to make sure that we do here is not just show a bunch of examples, but show how you can go and recreate those on your own. So this shadow example is provided for free through the local government solutions. So I just typed a search on Esri local government solutions, and I scroll down to the local government section. And there's a whole section of apps and maps for the local government planning community. And we see this review proposed developments. So these are a set of tools that we've tried to create a set of best practices, easy to follow, methods for supporting urban planning development review processes in 3D. And these are freely downloadable ArcGIS Pro projects that have tasks that are task-driven that walk you through step by step the processes that you need to go through to recreate the examples that I was showing here. So not only do we have the Evaluate Shadow Impact tool, which I was showing you earlier, but also doing visibility analysis, solar analysis, and there's a new 3D public survey app that allows you to stand up a 3D web scene and then create structured questions about a proposed new development and allow the public to give you feedback on this web scene or this new development that's coming into your community. And each of those survey responses are tied to the thing that the user was looking at when they submitted the question. So when they say, I don't like the view from here, well, what were you looking at? You go look at the question, we move the camera back to what they were looking at, and you can see exactly what the responder to your survey was looking at when they sent in the response. So again, I come from a local government background. I bring a lot of my local government experiences to things that we want to go build. Chris and Eric have shown a lot of stuff around the use of 3D in urban spaces. Well, not so that people kind of ask us, well, do you do something other than buildings? You know, I don't work around buildings. You got anything 3D for me? So I've got a couple of examples I wanted to go through and look at maybe some oceans examples, some things that I put together with the team for the Oceans Forum this past fall. So here we've gone off to the coast of California. This is down near the San Diego Convention Center. And we see that I've got the ocean's base map on, but the ocean is zero here, right? So there is no bathymetry. I can't see the ocean floor. So we have a content layer that is the Topobathy 3D. So this is both bumpy land and bumpy ocean floor. So now we see that I actually get to see the bathymetry of the ocean floor. So just like the World Elevation Service is just a global source of 3D data that streams into the browser. And then it allows me to go underneath the water surface and take a look at an example of artificial reefs. So there's an organization called the Reef Ball Foundation that has these cast concrete models of various sizes that can be placed on the ocean floor to create underwater habitat. So we created some static 3D models of that and used procedural symbols to then drop that on a series of points. It would allow me to put this in front of a planning commission, say, hey, this is what we're proposing to put here on the ocean floor rather than putting in hardscape on the beach. We could put kind of design with nature concepts. Well, what do we expect to come into this environment? Well, we'd actually like to see kelp and little fishies come around, right? So what we've done is rather than putting procedural trees like palm trees and oak trees, we've created a 3D kelp. And this can get hooked up to data that are things like heights and actually watch the kelp grow over time. So here we've got little kelps, and then we've got big kelps, and I can get even bigger kelps. So just an example of how we can do things that are kind of non-urban, but getting into kind of the urban nearshore fringe and dealing with some potential impacts of seawater or sea level rise. You know, one of the things that people kind of struggle with is how can we present scientific information in a way that's a little more human understandable, something that's a little more visceral that makes me want to act. Well, nothing better than feeling like you're going to, you know, the potential of drowning due to sea level rise. So here we have a row of homes along the Tijuana estuary, again, just south of the convention center. And we've got some tidal marsh areas over here. We've got some nice little palm trees and a row of homes that front the beach. Well, the research estuary that's down there has done some work to understand what potential sea level rise will look like in the year 2100. So this is what we see with a 1.6 meter sea level rise that's predicted in the year 2100. And we can see that the tidal marshes have been flooded. We're getting water flooding up to about the height of the car tire and just getting into some people's garages. Well, you know, not great, but not as bad as it could be. So what we wanted to also do is model what it would look like in a worst case scenario. So this is sea level rise with a storm surge and high tide. So this is with 4.4 meters of sea level rise. So I can very quickly see that there's a large amount of flooding. I've got these things that I immediately intuit, right? The height of a car, the height of a garage, the height of a tree. I don't get an inundation map that just shows this is flooded or that's flooded. Well, is it flooded by an inch, or am I going to be, you know, needing a snorkel, right? So I look at this and boom, I get it, right? So it's a great example of how you can present sometimes really scientific information, things that are kind of hard to get people to care about in a way that is more human. So that's underwater. Was today not water, and now potentially, or in the future potentially underwater. And we've looked at some city stuff. So let's take a look at another scale here that we're working in and going indoors. So thinking about doing GIS in the indoor environment. So we've got a solution that we've been working on that allows people to create a 3D campus environment. So this is the Esri campus, and in a lightweight web browser that allows me to navigate around my campus, be able to turn on and off floors. I can turn on the first floor, the second floor, the third floor. I can look at the exteriors or all the floors. But you know, maybe I need to actually find someone to get to a meeting with them. So if I want to search for this person, so we're connecting the occupant and an employee database and a related table to all of the spaces within the campus. Allows me to very quickly search and find someone. But you know, I don't happen to know how to navigate my way across this campus. I may be unfamiliar with the campus environment. Imagine this is a very large corporate environment. Maybe I'm a visitor. Maybe it's a mall. And maybe it's a university. I need to find my way to the class. So I want to route to this location. I'm coming from this office space, and now we're very quickly getting a route back, routing through the building, down a set of stairs, across the campus, and then over to that office. So we've got a routing network that not only goes indoors, but connects to the outdoor space and routes me across the campus. We see estimated time and distance, and I can then choose to route myself via an elevator should I need one. So how are we doing this? As I mentioned, there's a bit of a solution that we've been working on to connect these pieces. So we've got a collection of tools that allows you to take your CAD data and convert that into a geodatabase that goes basically from CAD to GIS. Once I get my data in a GIS, I can then perform a set of semi-automated tools for creating this interior routing space. We essentially overlay a fish network that becomes our routable environment, essentially a bunch of roads all over the campus. It gets me out of each space through the doorway, and then we connect every single office to every other office figure out where the centers of those where the center of the walkable spaces are, and then collapse all those zillions of individual routes into one collection of routes that heads down every single hallway and then across the campus. So you don't want to do that by hand. It would take forever. So now we have a set of automated tools that used to take about 40 hours to do for our entire campus, and now are down to about 4 hours. So now we're able to generate this routing network in a timely fashion. And then we can then publish those individual layers into ArcGIS Online or to your portal as a set of scene layers. And then we have this lightweight web browser that's just a JavaScript app that is configurable in a configuration table to work with your employee tables, any other type of business analytic data that you want. So there was just a release and update of these tools just over the weekend. And yay. And so if you search in ArcGIS Online, Campus Viewer Tools, all one word, you will be able to download a downloadable package with everything that I just described. So not one to sit still. Or the team, I should say. We want to continue to make the publishing and the use of your data much easier in the both the publishing workflow and in the app experience. So in the demo, the plenary this morning, Joe did an example showing the new filtering that's in the JavaScript API. So we have started working with that new API element while it was in beta, starting a few months ago, or actually just a few weeks ago. And worked with the ability to then filter these data. So let me go back to the released app. So you'll notice here that I'm starting on the 3rd floor in this building. I'm routing myself over to the 2nd floor in this building. And I've got all of these. I just have the 3rd floor on, and it's kind of obscuring the route over here. Well, I'd kind of like to just see the floors on that are part of my route. So I know that I need to get to this person's office, and I'm in a conference room. So I'm back in that same OA3 conference room. And now we see here that I have just the 3rd floor on over here, and I have just the 2nd floor on over here. So we're basically structuring a SQL statement to then tell a scene layer to just turn on the floors in OA3 3rd floor, and then the floor in M2. And I just want just those buildings on, and I want to filter out all the rest of the data. Another example of how we could use that filtering, I just want to see sets of buildings, and I want to turn those on and off by just their names. Right? So the data model is all there to support this. And we're flowing data into that. And with this filtering capability, we can then just filter across hundreds of thousands of features and be able to turn on just the stuff that I want to see. And because this is a developers conference, we have to show a very simple UI of something that's kind of a little beta-y thing, right? So how do I actually structure that? I go against my floor key ID. Actually, I should filter. I think I stole my thunder. So against the floor key field in my data, I send it that little comma delimited string, and I can then control individual floors one at a time. Right, so very simple implementation of, you see that kind of what's new in ArcGIS Online. You get this bullet list of all this stuff. Oh, filtering, cool, next, this thing next, this thing next. Well, this is one of those like seemingly really simple things that actually starts to open up a lot of capability. So we're pretty excited about it. So I'm running out of time here. I have one last little thing that's kind of fun. If I learned anything from The Shining, all work and no play makes Jack a dull boy. So let's go have a little fun with connecting story maps to 3D data and a mountain bike ride that I did with a buddy at work not too long ago. An example of how we can kind of share our experiences out in the outdoors with people. So we did a big mountain bike ride up in the just west of here, not too far from the from JPL, if anybody's familiar with that. This is a watershed, and we wanted to ride around it. So I used the watershed delineation tool. Yay, free service. I just plugged in a point and it figured out what was up an upstream watershed, threw that on the map. And we can put some pictures. Here's this ugly looking dude who needs to shave. That's me. And basically took my route out of my GPS unit, brought that into Pro, did a little extrusion, published that as a scene layer, dropped that on the map, and we can see the route that we rode around. And then I can create different slides of different places along the trail, places where I took pictures, different forks in the trail, and I can then reference the web scene, and I can reference that slide in the story map, attach it to each one of the segments, so that as you scroll through it, I can say, hey, here's a fork in the trail, it's a little hard to find, it's right here on the map, this is what it looks like, blah, 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 blah. We had some fun here. So this could be used for practical purposes beyond just having fun. You could imagine that I'm telling a story about some analysis that I did, or there's a project in my city. LA City did something about pushing 2 years ago now, where they put all of their major projects for urban development in a story map, took people around the city, showed them the project, linked off to the project page, tied it to a map. And that can also be done in 3D as we see here. So. All right, I'm going to switch back.
So there's so much stuff that we have to cover, right? Earlier I kind of just said it's not 3D, it's just GIS. One of the big things about 3D is getting you lots of data to build apps with. And I'm just going to quickly show you something. GIS used to be the original big data, except you couldn't use billion or giga. Well, now you can use billion or giga when you're talking about GIS, and we're actually making it happen. What I'm looking at here is, in addition to the 40 terabytes of elevation service behind this and about 260 gigs of imagery, what I have here is 420 gigabytes of integrated mesh scene layer from Vricon that will page in, and man, online is getting hammered right now. That's all I can say. But it'll page into half meter resolution, and usually it's a lot faster than this. But I think there's probably like 3D talks going on at the same time talking about scene services right now. Then here is 1 billion points in a point cloud that'll also stream in, and like I said, we're just hammering right now online. And then here is 5 Revit models in the same scene. So we are working hard to get you guys the data that you need to build apps, workflows, and new technologies around this massive amount of new content that is coming. So we have a couple minutes left. Does anybody have any questions? I'm sorry, Eric. Yes, sir. Actually, I get this. So there are actually a couple of samples up in ArcGIS Online. If you search for Vricon, you'll find a couple of examples up there. There's one Yosemite patch and a Southwest US patch that have their attribution on it. We're going to be working with them to make sure the attribution is on all of the data sets. And they're going to be directly sharing out some data online with their own attribution that you'll be able to download and use, actually. So you can use it locally in Earth or Pro, and you can use it as services as well. So yeah, that's for, and if you need their contact there, I can put you in touch with them. Other questions? Was this interesting, guys, and giving you some new ideas? And do you see 3D coming as something that just is inevitable in GIS? Good, some nodding. Go ahead.
I have a client that won't leave Google Earth because they like being able to check that box that says 3D buildings and urban areas come in with texture files. Any chance that you're going to be able to hook into a 3D warehouse?
That is different from the Google 3D buildings is different from 3D warehouse, but which is now Trimble 3D warehouse. I estimate that Google spent about Esri's annual revenue on data collection, and we're not going to spend that kind of money because it would be bad. So I'd have a hard time convincing Jack of that. But the future is probably going to have to be through monetized services, and we've got partners like Harris and others that can produce buildings. Pictometry is another one, and there are more. The AEC market is desperate for that. About 40% of our beta users in Earth were AEC self-identified. That was a big surprise to a lot of Esri folks. I figured it coming out of the AEC world. And they want badly. Commercial real estate, that's another group that wants it really badly. Jim knows that really well. And so we'll try to do some target areas, but it's probably going to come through services with partners. So.
Even through some sort of like licensing from Google?
No, that's not going to happen. So yeah, just easily, and Apple is even less likely to happen. Yeah, sorry. But other questions? Yes, sir.
So it seems you can support other 3D models besides buildings and stuff like that.
Yeah.
If I wanted to, could I do a flight simulation game?
So actually one of the oldest JavaScript demos is a simple flight simulator using our JavaScript API. It depends on what your expectation is. So the true modeling and sim experiences bake everything down to a massive mesh and just serve you very regular tiles of those meshes at just the right time to make a really optimized experience. But could you build an experience where you could navigate through GIS data that's streamed in and is pretty fast? Absolutely. You could do it even on top of Pro with the API there. You can definitely do it with the runtime APIs and the SDKs. And then you could even build a JavaScript experience that's a flight simulator. So, for sure. In fact, that old JavaScript experiment, it's still up there somewhere. It's a multi-viewport viewpoint. I think it's got 3 or 5 views on the same web page, and there's one that's just a top-down 2D view of a plane moving, and you have some simple controls to make the plane go up and down, and then it changes the 3D views next to it. So yeah, you can definitely do things like that. So we'd love to see more people experiment with stuff like that for sure. I didn't hear that. Somebody else say no? Okay. Anything? Oh, it's outside. It's hitting me right directly. Any other questions? No. All right. Well, thank you all very much for attending. Pleasure having you. All right.